Hello, welcome back to More Fun Fixing It, and it's time for another ZX Spectrum repair because you haven't had enough of those already. This one is a 6A which has HC strange screen colours. I don't know what HC is. Nope. HC. No, Paul, you're going to have to let me know what your acronym stands for. But a 6A is something I don't often get to repair, so this should be a bit more interesting than your standard issue 2. I've already taken the screws out. It's in a plus case, which is quite, usual for, or something you would expect to see with a 6A because they came later when the plus was about, and this, if it came out of the factory, this is what they would have put in a plus case. But you're not guaranteed to get them in a plus case, because they also sold the plus cases as upgrades, but this one should have a serial number on it. Oh, it hasn't even got a serial number on it. Normally I have a serial number there, but if they haven't got a serial number, they usually have upgraded. But this one hasn't got anything, so it's making me look like a complete liar. So that previous video where one of the springs was missing, I found it and it had fallen into my pocket on my hoodie. I don't know how it got there, but later in the day I put my hands in my pocket. I thought, there's a spring here. So that was complete. That was all good. Now, so strange colours. I'm not going to plug it into a display, and I'm going to do my normal tests first. I've got two ways of doing this now. One is to just chuck the Steam Card Pro onto the edge connector, connect up power, turn it on briefly with a limiting or current limiting power supply, and see if the voltages appear. And I'm not going to do that this time. I want to run through the normal procedure like everybody else really should do, because not everyone's going to have a Steam Card Pro or current limiting power supply, and if you just plug it in with your normal power supply, you could do quite a lot of damage. So let's do that. Where's my so we need, first thing you need is a multimeter, and I'm going to put it on resistance. The first thing to check is resistance between ground, so you can get ground anywhere on, like this heatsink or the can of the modulator or the center pin of the voltage regulator, and then the outer pins of the voltage regulator. So the top one is the output pin, so that one is connected to the 5-volt rail. Ooh, I keep slipping off. And that's about 1K. That's fine, I think. And the input pin is 4 meg. That's fine. So keeping the black lead on ground, I'm going to measure the voltage rails for the 4116 memory chips down here on the lower RAM. So the top, the left one is pin 1, and that is fine. It's 3.7K. And the bottom left hand one, which is pin 8, is 2K. And the bottom right one, which is pin 9, let's go, is about 1K. That is a little low. I would expect it to be up over 2K. What if I've got a board I can show that? Okay, ignore all of the speakers connected to this one. This hasn't got everything connected to it, has it? Oh no, I think this is a broken one, but it's an issue 3B, which is not a direct comparison, but the voltage rails should be fairly similar. Okay, so 1K, just over 1K on that one. Where are the other ones? Pin 8 is 2K and rising. And 2.5 meg on the top one, on pin 1. That's 3.7K. So there is something going on with this one. And the next thing I'd like to check is the coil, staying on resistance mode. And I've usually, by this time, I've got my black lead in my left hand and a red lead in my right hand, and I'll check across the coil like this. And you want an open connection, and there's resistance there. But if you see that, then swap the leads around, and it should go to OL. And then on the top one, should do the same thing. Oh, that's a, what? That's a dead short, but it keeps coming and going. That is really weird. So it's open that way. So I don't think there's anything wrong with the coil, but there's something in the circuit that is pretending to be shorted. It's not now. It's 5.4 meg that way, but you would expect that to be open the same as, oh, that's there as well. Although they are, I mean, that's that and that. Those two corners are, no, sorry, that side and that side should be connected. Dead short, and that side should be a dead short. That's very strange. With that in mind, there's something a bit weird going on there. Normally, if I find a short here, I'll then start looking down here for the voltage regulators, TR4 and TR5. Not the voltage, sorry, the transistors TR4 and TR5 voltage regulators, to make sure that they're okay. TR4 is usually blown, and the way to test those is to put the multimeter into diode test mode. Now, your multimeter might be different. Mine, I've got different multimeters that show me different readings for these, but I just know how this one works in this situation. So black lead in the middle and red lead on the top gives me open and open, and then red lead in the middle, black lead on the top, 6.6 and 6.6. That's normal. So that looks like TR4 is okay. This is TR5, black lead in the middle, 0.7, 0.7, and then red lead in the middle should be open one way and 1 point something, yeah, 1.08 the other way. That's acting normal. So I think this part of the circuit is actually okay. I'm actually going to use this. This is an LCR meter, and I don't often use this, but it's really good. Well, it's not really good, but it's actually not bad for testing capacitors in circuit. In this situation, you shouldn't test capacitors in circuit. That's it's a bad idea, but you kind of get a feel for when something is good or bad in a spectrum by doing this. So that's, I'm looking for the capacitance and the resistance here. So that one says 69 microfarad and 2.7 ohms. I think that's okay. And this one is, and these are 22 microfarad, 17 microfarad and 11 ohms. That's a bit higher. That's something to keep an eye on. And this one's 1 microfarad, and that is reading exactly that. And that's also reading 27 ohms, so something to keep an eye on. And this 4.7 is reading 5.2 and 11 ohms, another one to keep an eye on. Not too bad. I'd like, ideally, them to be under 5 ohms. But again, they're in circuit, so it's really difficult to say. This is a 1 microfarad again, 1.1, 24 ohms. The 1 microfarads do tend to read in circuit a bit higher. This one's another 1 microfarad at 26 ohms. This is a 22. Ooh. Which is really reading the same as that one over there, 69 microfarad. So maybe there's something in circuit that is messing around with these readings. Let's finish off these 22s. That one's fine, 24 microfarad, 6.9 ohms. That one's perfectly good. 37 microfarad, 3.4 ohms. Again, I wouldn't change that. These are 100 microfarads. 115 and 1.3, that's good. 113 and 14.8, 14.6. I don't think it's the capacitors. There's a couple there that are probably marginal, but in an issue 6, I would say, or an issue 6A, I would say that the caps are more likely to be okay These are still the Gellert ones, which are, or Gelec ones, which are not always good. There's a cross on the speaker there. I'm wondering if that's a problem as well. Well, it's not shorted, so that's okay, but it's reading 5 meg, which is wrong. So I'll have to remove the speaker. Okay, so the next thing, now that I've done all of those checks, the next thing I want to do is to plug in Steam Card Pro, plug in a power supply with 800 milliamps current limiting and 9 volts, and then switch it on and see what happens. Okay, it's current limiting. I saw up there, I didn't look down here, so I'm going to do it again. Yeah, the 12 volt flashes on and then flashes off. So we've got 9 volts, 5 volts, but no -5 and no +12. So something is definitely bad on here. It's not really been on long enough for me to feel if there's anything hot. So at this stage, this is the point where what I would do next, and what somebody else with less equipment to help them on their diagnosis would do. So if this was somebody that just had the basic setup of multimeter, I would probably start measuring resistance on all of the lower RAM to see if anything looked unusual. We can just do that, see if anything strikes us as unusual there. I normally wouldn't do this because it's going to be probably a waste of my time. But for the sake of education, mine, let's have a look. So this, I think this is the -5 volt rail. I need to put up a pin out for the 4116. Okay, so it's another thing about measuring these resistances in circuit is there's capacitors in circuit and things change. So yeah, it looks about the same. Oh, okay. So that one's 4K. And this one's 3.5. And this one's 3.5. So there is a difference. Nope, that one's 3.5 as well now. See, this is the problem. And that one's 4K. That one's 3.5. Is that one still 4K? Or 4.5K? No, it's gone back. So this is going to be almost completely useless. That one's 4.5, and this one is still 3.5 and climbing. Is this one still? No. How are you supposed to know? Right, 6K. We got a solid reading on that one. 6K on that data line. 6K. 6K, so 6.5K. 6.4. 6.4. So it could be a really minor difference and difficult to find. This is why I don't usually go this way. 6.4. 6.4. So another power rail. This is either the +12 or +5. Again, they're connected to capacitors, so really difficult to measure reliably. And literally connected together. So the bits that aren't connected together are things like the RAS and the CAS and the address lines. But the address lines are still actually connected together. They're all paralleled across. So if I can measure this one, 1.004, this should also be 1.004. So yeah, measuring resistance, not as useful. Another thing you could do is, if there is something getting hot, you could turn it on and hope for the best. They will tolerate being switched on for a few seconds, but you're not going to be able to, unless it's a chip that gets immediately hot, I don't think it's going to help you. But I've got a thermal camera, which I'm going to turn on. These are getting cheaper and cheaper, but I would say it's probably still out of the reach of someone that just wants to fix a Spectrum that they bought on eBay. So not ideal. So it's not been switched on, so I'm not really showing anything that's getting untowardly hot. So let's turn it on and see what happens. Oh, we've got a live one. Okay, we've got 2 chips, but yeah. Okay, yeah, that one and that one. This one's getting a lot hotter. In fact, they look different to the chips around them. These 2 look the same as these ones, and these 2 look different. So are they different date codes? 83, 8437? No, they're all out of the same batch. They just look different. But that one was immediately 30 odd degrees, and this one, I didn't get a temperature reading, but it started to glow more than these ones. So I reckon the first thing I should do is take that one out and see if the voltage limiting then disappears. Be nice to know what the voltages are. Oh no, we know what the voltages are because they're not there. Right, in this video, I'm going to make sure I take out the right chip, just for a giggle. Although that doesn't seem like much fun, does it? I can't go too far wrong with the first one. Let's just hope, this is the thing. I'm just about to say, let's just hope this is an easy board to work on. And this is one of the things that you just cannot know. This could be an issue 1 to an issue 6, and you just don't know what kind of quality you're going to get when you start desoldering things. It could be one of the ones where all of the pads just want to float away. So I'm going to give it every chance, especially on this first chip, of coming off cleanly by flowing some fresh leaded solder onto each pad, and then using the desoldering station in as gentle a way as I can to remove this chip. The good thing about this one is the chip seems to, well, all of the chips seem to have not been trimmed. Oh, some of these might have been. No, all of the legs are all still there. This is a good sign. It makes it a lot easier to take chips out if you've got a leg there to actually push against. If the legs are bent over as well, these are all straight. Okay, let's start here, I think. Difficult to know. I'm trying not to dwell for too long. In the corners where they're connected to power rails, one's connected to ground as well, I always try to leave the soldering iron just a few seconds more, just so that the solder can melt all the way through. Then everything else is connected to a thin trace, and so you need to be a little bit more careful. And the pads on this side are just stuck down. There's very few, I don't think any of the, oh, there's one trace there. So there's nothing, there's no thermal mass there for the pad to absorb the heat. There we go. Hopefully I've edited that one so that it's in real time and you get a good idea of how long to give each pad. Next thing I'm going to do here is use a pair of, these are like bent tweezers. I can't think what these are called. Forceps, or I don't know. I need some better ones of these, or I need to take that pin out because I keep pushing that and it sticks through if I really squeeze hard into my thumb. So I use these just to give these a little tweak, just to not too much because I don't want to stress anything if it is connected, but sometimes, or quite often, they are just connected by a little bit of residual solder, and you just need to give them a little tweak and it will come free. Get my words out today. So the next thing I'm going to do is use my snub blunt nose flat tweezers. I've got a couple of pairs of these. This pair as well. These are a bit of a favourite of mine. And they're kind of rounded on the back. So when I slide these underneath the chip down here, I'm not going to damage anything underneath, or I have less chance of damaging anything underneath. Because anything sharp on this side, if it was like a sharp edge there, I'd have a good chance of scraping off traces. Now that's not moving. I'm just giving it the very slightest pressure to try to lever that out. I'm not trying to lever it out, but it's not actually moving. If it was going to go, it would just go crack and come out. So now I'm going to come in with some hot air at 330 degrees, and it will come off very quickly, again in real time. Just a little bit of pressure. Starting to move. Don't go mad. There we go. That came out a little bit quicker than I wanted, actually. I pulled it a little bit faster than I should have done, so maybe a little bit more patience, but all of the traces are still intact. Looks good. Here we go with my favourite DRAM tester, which I need to plug in. I need to change it to 4116, like that. And there's an LED lit up here to show me that I need to put it into this socket with the notch at the top. So pin 1 is over here. And here we go. Definitely broken. Very, very broken. I'm quite curious what my old 1-bit tester, will make of broken chips now, because there's been a few times where this hasn't picked up problems that this has. So 4116 on that side, yeah, that's just immediately shorted. That's just a bad chip. I've got a feeling that maybe more than one of these are broken, but let's see if we have any voltages now. Okay, so I've got the Steam Card Pro in and power, and I'm looking here for the voltages. Yes, we have voltages. Oh, it's still current limiting. Okay. I mean, we're missing a chip, so that's obviously going to be impacting things. But now I want to know if the next chip along, now it's a bit safer to leave on. There is 12 volts there. In fact, let's see what voltages we have got. Right, I've got the black lid clipped on this time. Let's see. Voltages. Let's see what we get. So -5 is -4.7. That's not actually too bad. That's not terrible. +12 is +8. That's pretty bad. And the +5 is 3.7. That's not very good. So what have we got over here with the 5 volt coming in? 3.7. Bad socket, maybe? Give this socket a squirt. Try the 5 volts again. No, less. 3.7. What is the... right, okay, so... You can immediately see. I thought that this would still be lit up from being heated, but no, there's a hot chip there. Okay, so that other one, that needs to come out next. Oh, that one, which is IC11. Let's pop that out and try it again. Like I said before, if you were at home and you know, you didn't mind losing all of your chips, you could just turn this on and spray some isopropyl alcohol on here and watch to see which one dissolved the IPA first. But in the meantime, you might lose some more of them if it was just that one. But how would you know? It's really difficult to know unless you've got very sensitive fingers. That's all. I haven't. Okay, so this one I'll speed up a bit because you don't need to watch it all twice. Here's the bad chip, or the suspected bad chip. Still a bit hot, but that should be okay. Okay, they're exactly the same fault as the other one. So, two bad 4116s so far. I think we might be in for a ride here. But then again, it might just work. Okay, right, looking at the current limiting. It's no longer current limiting. All of the LEDs are much brighter than they were before, and I think it's running, looking at the activity on the LEDs over here. Yeah, right, so with this switch over on the left-hand side, you see the data bus activity is actually counting across them. Right, so that's now well enough that I can put two sockets in here and two replacement 4116 chips, and then we'll see what that does when I connect it up to a display. Sockets. Yeah. There we go. Okay, I think I've got, yeah, these are 4116s. These look new. I can't remember buying these, but I probably bought them on AliExpress fairly recently. So let's just, before I just go stuffing one in there, stick it in here and see if it passes the test. Oh yeah, looking good. All right, and we need another one, don't we? These do look new. Yep, two passes. I just use my leg straightener to get these back into shape. Right, now I need to connect it up to capture, and this one hasn't got composite mod, so I need to use my special, be quiet you, my special Henry tool here. Actually, oh no, I have tested the voltages. No, one thing I haven't tested is the voltages. Let's just make sure that this is showing the correct voltages across all the voltage rails. Right, here we go. And so we've got minus, yeah, -5. That should be minus, that's not right. That's current limiting. Why is that current limiting? This one's going into meltdown. That's up to 40 degrees straight away. Let's pop those out again. It could be I've got a short somewhere. Okay, it's not doing it with that chip in there. That chip not in there. What about if I just put one of them in? Yeah, that current limits. I think this needs a recap. I think that's the problem with this. I think the DC-DC circuit is very fragile, and there's enough resistance on one of these voltage rails that drags down one of them, and then you get an unbalance, and the voltage balance, or the voltage the voltage bias shifts enough that the chips actually, that's probably what killed these ones in the first place. I better check these now to make sure that they're not damaged. That's okay. What about this one? Okay, that one's dead. Yeah, we killed one. Ah, I've not had that happen before. They normally can tolerate just a second or two of being switched on without the correct voltages. So without them in there, there's, you know, the resistance is okay. Maybe these ones have got higher resistance on their voltage rails than these ones have. But with that extra resistance on, the voltage disappears. So this is a good one. I'm going to risk it again. The voltages are there, but it is current limiting. Has that killed that one? Yep. Okay, yep, so there's two 4116 chips there that have now expired after being plugged into this board. So the most sensible thing for me to do at this point is to whip all of these chips, capacitors out and put new ones in. I'm also going to change TR4 and TR5 to give it a whole new DC-DC circuit. I'm hoping the coil is okay. It looks all right, really. I'm also going to remove the loudspeaker while I've got the desoldering iron hot, and then we'll go from there. But once that's all back in place, I think that this will be. I think that's the problem. I think this will fix the problem. It could be some other chips have also expired. Could be that something on here is also dead in a way that's affecting the voltage. Mind you, that was fine. Without that in, that doesn't current limit. It's drawing 500 milliamps. Very, very peculiar. Okay, let's do all of that. I'm going to take out the speaker, these transistors, all of the capacitors. Oh, there's one here at C80. I didn't test with the LCR meter, and it's fine. That's what I'm going to do, and hopefully it won't chew up any more of my chips. Okay, I've started off by marking all of the positions on the back side, so it makes it easier for me to go around and do all of these at the same time. There's so many different ways of removing these. A sensible way to do it is to just chop one leg off and then heat them from the top and pull the legs through. That is a fairly easy way, but I quite like to take them out whole. I've got a desoldering station here, which has been on for the last half an hour. So I'm going to use my desoldering station, but that just means that I have to, first of all, go around with my soldering iron and straighten up all of these legs and reflow them at the same time. Now I can just pop round with this and free them all up. A couple of those just fell out. Okay, so those are those ones from there. That one is from there. That one's on its way out as well. That was one of the ones to keep an eye on. So let's have a look. See if any of these are showing up as abnormal out of circuit. Right, this is a 22, 27, 4.7. That would function fine. This is a 1 microfarad, 1.1. 18.8, 19, and the resistance is climbing. That one I think might be a problem. There's the other 1 microfarad. Yeah, similar with that one. 20.6, 20.8, yeah, 21 and 1.2 microfarad. So yeah, maybe. So look at these 22s. These ones are quite high resistance over here. No, that looks fine. 18 microfarad and 9 ohms is fine. And this one, 29 microfarad, 4.8 ohms is fine. This one is another 1, I think. Yeah, 1 microfarad. .22 ohms. Well, maybe it's just these old caps. They're all doing the same. And the 4.7 is 5.2 with 8.8 ohms. Hundreds. Come on. 100 microfarad. Hello. Hello. We've got a winner. This 100 microfarad cap, 16 volt, is reading 9.3 microfarad and 152 ohms resistance. That's a bad cap. That could be the whole thing. It's nice to actually find one because then it means I don't have to chase her off around the rest of the board. So this one, the other one, there's 2 down there. One of them does the lower RAM. I'm pretty sure that it is the bad one. Controls the 12 volt rail for the lower RAM. The other one does the 12 volt rail for the video chip, which is usually an LM1889N, but in this one is one of these horrible SN9445 something. They're terrible chips. If the display is really bad, I'll just swap that for an LM1889N. So this one's fine. That one's okay. And these are the 22 microfarads that are over here on the video end of things. 25 and 5 ohms, that's fine. And 26 and 2 ohms, that one's practically new. It's probably better than the ones I'm going to put in. So we've got one bad cap for sure. And the rest look mostly good, and if not good, good enough. I would normally leave them, but because I've got them all out, I'm not going to put them back in. There's no point in that, so they will go in the bin and I'll get some new ones in. Yeah, which I've got here now. Taking all of the caps out at once is probably a bad idea for most people. I generally know that those are always 22s. There's a 1 and a 4.7 here. These are 1s. Oh, I forgot this one. This one that was a different colour keeps evading me. This is a 22 microfarad, 25 volt. And that one's reading 19 and 2 ohms, so that's fine as well. Yeah, 22 microfarad. Yeah, 1 microfarad's there. 100 microfarad, 22 microfarad, 22 microfarads here. But I always still print a map out every time I do this. I should keep these rather than reprinting them, which has the polarity on them and the values on each of them, so that I just don't make a mistake. Take all of the doubt out of it. So we've got the 3 1 microfarads. I'll do the 4.7, 3 1s, all the 22s, and then the 100s. Right, I'll wash that off in a bit. So before I do anything else, I was going to change everything all at once, but I want to make sure that I know what's going on here. So I'm going to, I am going to get another 4116 and put one in to here, and then I'm going to power it up and see if it stays powered up. Make sure this is a working one. That one works. See if it current limits this time. Right, so here we go. No, it's not current limiting. So I'm going to put another one in. That one's good. Okay, now with all of this connected, will it current limit? No, it's working. Okay, well, I say it's working up to a point. It's not, the DC circuit is not collapsing like it was a minute ago. So I'm going to connect up my Henry comp mod. My instant Henry comp mod. It's not an instant Henry, it's an instant comp mod, which makes a lot more sense. And let's see what we get on screen. Oh, the pitch quality is down to this connector just being really nasty and gnarly. That'll do. Let's leave that like it is for now. Okay, it's passing. It's passing. So can I make that look? Yeah, I just need to clean this socket, but I'll do that when I composite mod it. So I'll do that now. Super quick composite mod. Right, this is looking pretty grotty inside this socket in here. So I'm going to get a brass brush pen. It's got some stuff on it. But I'm going to stuff some contact cleaning down there first. In fact, I'm going to spray some on the brush as well, and see if I can get that in there. Yeah. That's, the inside is probably mostly fine, but this outside bit, to get this off, is crusty as well, so that's going to need a bit of a clean. For the outside bit, I like to use a bit of sandpaper, very fine sandpaper, but I haven't got any with me. So again, with the contact cleaner on a bit of nano sponge. Yeah, that's doing a good job. It's not quite as aggressive as I might have gone for with the sandpaper, but it's doing a really good job of cleaning that. Yeah, that's good. Right, now this is working. I don't want to risk it anymore, so I'm going to put it back in its case loosely and connect everything up. Should get a better picture now. It's a little dark, but that's fine. It's good. Right, so next I just want to test this keyboard. I did notice something here in this connector here. Zoom you down. You just see there's something in there. A pair of sharp tweezers, and not sure what that was, but I'm not going to risk sticking the connections in, the ribbon cable in there without that being cleared out. So I don't know if this is going to work. Usually on 6As in pluses, the keyboard membrane is okay. Oh, of course, we've got no speaker. And we've got only... Oh, hello. No, we've not got very many keys working here. Might need to just trim this ribbon cable a bit. Yeah, the ends are looking, oh, that one's peeling up. There's something going on there. It doesn't look good, so it's kind of grimy as well. Speaker. Zilch, nothing, nada. It be broken. I've been experimenting with these. I don't even know what ohms this speaker is, but I think it's something like 30 ohms, and they're meant to be 40 ohm speakers. And I think I've put in a resistor in line here that should make this a working specky speaker. A bit bigger than the standard one, and this capacitor is in the way, so I might have to go for a smaller one. No, I've got some smaller ones as well somewhere. Okay, I found a slightly smaller speaker than these ones. Don't do that. I'm gonna rob the legs. Oh no, I might have put some UV resin on there. I'm gonna make some new legs. Yeah, I've UV resin that, and whatever that resistor is in there, I'm gonna make a new one of those as well. And then I'm gonna stick it in there. Okay, just going to put this one side in first, so that it will hold it in place. Quite a lot of solder on there. Now that's going to give me room to put the resistor in line with this connection here. Right, I don't know how much footage I just lost, but I found a suitable speaker, and I've connected a 10 ohm resistor because this speaker is a 32 ohm, I think, and it's meant to be a 40 ohm speaker. And this, I don't know the science behind it. People will probably pitch in and say that you don't need to do that, but I did it without it with these 32 ohm speakers, and the TR7 started getting hot. So with a 10 ohm resistor in line, it brings it back down to the expected levels. I don't know why it works, but it does. I did look it up, and I did read about it, and impedance and impedance, not impudence. I keep saying that. I'm sorry. And yeah, I looked it up and then I forgot all about it. So you'll have to look it up yourselves if you want to know. Cable, cable, cable. Right, we should have sound now. Yay! You hear that? Eee. Lovely. Okay, so if we've got sound, oh yeah, keyboard. So I'm just gonna slice off a good chunk of this actually, because it looks pretty grotty on that last bit. So I'm just going to take off, you know, probably 3 mil, or I'd normally take off just 1, like that. Same with this one. There's quite a lot to quite a lot spare on these, so hopefully that will be enough to make a good connection. Same problem. I better check it with a known or a good keyboard actually, just in case it's a socket problem or a ULA problem even. Okay, I've got a keyboard from another Spectrum here that's already been repaired, and I'm pretty sure this one works. I can't find the membranes. Paul gave me a bunch of them, and yeah, I've put them somewhere safe. All right, let's try this. Okay, so it is the membrane. That works fine. So what I'll do first on this is try to just take the pressure off of these clamps. I might put a piece of card in or thick paper in each of them just to put a bit more pressure on. That's the only thing I can try. And maybe take a bit more off of that. I don't think it's that. Let's try the clamps. So there's two halves of them, or two layers of this membrane that are being pressed together under this clamp. You can see in there. I'll give that a little wiggle around just in case there's any corrosion in there. And I'm going to put a piece of paper in there. It doesn't have to be thick, just to put a little extra pressure on it. Like. I'll do the same on this side. This side looks a bit more problematic. You can see, I'm not sure what I'm seeing there, whether that's, yeah, there's the black edges of the, you don't know whether that is going to make a good connection. There's 3 layers on that side. I think it's just 2 on that side. Has that brought it back? Because it's not gone. The membrane is all there. No, same problem. Bad membrane. Nothing I can do about that. Okay. All right. So we did have 2 bad 4116s. I've lost one though. It seems to have launched itself off into the nether regions of my workshop. Yep, it's gone forever. I'll never find it again until I stand on it with bare feet. And it also managed to blow 2 more 4116s. Had a bad speaker and a bad cap and a bad keyboard membrane. But now it works. Yeah, I could play some games at you now, but I think I'll spare you Manic Miner this time, and we'll see. Paul will test this when he gets it back. He'll load a game via tape. That's something I don't really have time to do. I'm happy to fix all of these, but I don't want to be doing all the testing. Paul's got to do some of the work. So Paul gets them back. He tests them before he sells them on. So he makes sure that they fully work with the normal things like loading things from tape. And yeah, he'll do the final testing and then put these on eBay. And he'll also do a bit of cleaning as well. I'm not doing that either. God, I'm so lazy. Right, anyway, that's all for this one. Thanks for watching. I hope you enjoyed that, and I'll see you in the next one. Goodbye. That took longer than I expected.